This video is Module 3 going through Example 5. In this problem, we've been given the null hypothesis that pi is equal to 0.4, the alternative hypothesis that pi is less than 0.4. The sample size is n equals 50. I do 100 repetitions in a simulator, and it tells me my sample statistic is p hat equals 15 out of 50, which is 0.3. And I give you a picture here of the actual simulation that I did with the Rossmann chance applet. And there's going to be a series of questions that we're going to answer in relation to all of this. Part A, what value would this distribution actually be centered at, and how do we even know that without that summary stats button being selected? Now notice, if it had been on proportion of successes, if that had been the button selected, we know that the distribution would be centered at pi equals 0.4, approximately, since it's a simulation. It won't be exactly 0.4 since it's a simulation, but it would be close. But it's actually selected number of successes right now. See, along the horizontal is number of successes rather than proportion of successes. So what it should be centered at is 40% of 50. The sample size is 50. So we expect our sample statistics to come out near 40% of 50. So 40% of 50 is 20. So it will be centered at 20. And when I say it should be centered at 20, since it's a simulation, it will be approximately 20, near a mean of 20 if you hit the summary stats button. Next, part B asks, if we switch to proportion of successes for the graph, what value would the distribution be centered at then? That's actually easier to answer. It would be centered at pi equals 0.4, or since it's a simulation, it would be approximately 0.4. Next, part C asks us to find the p-value. We can actually use this given distribution, this simulated null distribution, to find the p-value. Recall, if we assume the null hypothesis is true, then the p-value is the probability of getting a sample like ours or more extreme. So, in this situation, our alternative hypothesis is pi is less than 0.4. We need to count sample statistics, the dots in the distribution, that are like our sample statistic or less. Because the alternative hypothesis says pi is less than 0.4, we will count sample statistics that are like ours or less. So I go to my distribution. Notice there are 100 total dots here. I know that because it told me that it did 100 repetitions in the beginning of the problem. I can also see that there's a total of 100 here in the simulation screenshot. There's 100 total dots. So I first locate my observed sample statistic, which was 15 out of 50. So that's right here. I'm going to go ahead and just put a vertical line right at where our p-hat is, and I'll label that. My p-hat is 15 out of 50. There it is. And now I'm going to count the sample statistics that are like mine and lower. Okay, so right at p-hat equals 15 out of 50, there's 1, 2, 3, 4, 5 dots. I got to count those 5 dots and all the ones that are less than that as well. So there's 5 dots right at 15. Then there's additional 4 here. So there's 5 right here, 4 more here, 2 more here, 3 more here, and 1 there. That's 15 total dots out of a total of 100 total dots in the null distribution. Okay, so part C again says we need to count the sample statistics, the dots that are like our sample statistic or less. That's what a p-value is. If you assume the null hypothesis is true, then this is the distribution we would get, the distribution of sample statistics. And so our p-value is 15 out of 100, which is 0.15. Our p-value, the probability of getting a sample like ours or less if the null hypothesis were true. Part D asks us to write a sentence to give the exact interpretation of that p-value. So we would say, if we assume the population parameter is truly equal to pi equals 0.4, then the probability of getting a sample statistic like ours or less is 15%. 15% because our p-value is 0.15. Part E, what conclusion do we make about the hypotheses? So this is where we're going to say that the null is plausible or we have strong evidence in support of the alternative. Notice our p-value is big. Our p-value is bigger than 0.05. And when you have a big p-value, you'll conclude that the null hypothesis is plausible. So since our p-value is bigger than 0.05, we conclude that it's plausible that the population parameter is truly equal to pi equals 0.4. All right, and Part F. Part F asks us to describe how to make the computer simulator find this p-value, and then we're going to go to the computer simulator and do it. Now, when we actually go to the computer simulator, we have to realize that every time we do a simulation, all of our simulations will come out a little bit different. And so when you try this at home on your computer, and I try it here in a moment, our distribution is going to look slightly different than the given distribution here from when I use the simulator another day. And yours will look a little different, and mine's going to look a little different. And that means your p-value will be a little different than mine, and my p-value will be a little bit different than the 15 out of 100. However, your p-value that you get when you do the simulation and the p-value I'm about to get will be similar to 0.15. I will still get a big p-value that leads me to the same conclusion overall about the null hypothesis. That the null hypothesis is plausible. I expect that you're going to get a p-value somewhere between 0.1 and 0.2, around there. So let's give it a try. All right, I go to the Rossmann Chance applets. I open up the one proportion inference app. Okay, so our probability of heads. In here, we enter the value from the null hypothesis, which was 0.4. The number of tosses, our sample size, was 50. We're going to do 100 samples so that we see 100 simulated dots here. And I'm going to go ahead and hit draw samples. There it is. Notice it's still centered around 20. It looks a little different than the one that I had in the lecture guide, but it's very similar. If I switch to proportion of successes, it will be centered around 0.4. Yes, so you see it's around 0.4 in the middle. All right. How do you actually go about finding the p-value here with the simulator? Remember, we want the computer to come here and locate 15, which was our observed statistic. Our observed statistic was 15 out of 50. So we want it to locate that and count the samples that are like that and lower. And to do that, you're going to use this area here, the as extreme as count area. So the first thing you want to do is you want to come here into the little box and you want to put in your observed sample statistic. Be very careful. If you're on number of successes, I would enter 15. But if you're on proportion of successes, you would have to enter 0.3 because 15 out of 50 is 0.3. You need to make sure you're really clearly aware of which button you have pressed and that you put the correct count in here for your sample statistic. So I'm going to just go ahead and put it on number of successes, and I'm going to put in 15. We saw 15 successes in our observed sample statistic. The next thing you got to do is you need to select this box to match up with your alternative hypothesis. My alternative hypothesis was a less than symbol. Pi is less than 0.4. Notice, if I have it on less than, it turns all the dots red that are like mine and less. If you accidentally have the other way switched to, it'll count those and higher. That's not what we want. We want it to be like my sample statistic and less. Please note, when you have an example problem where you need to do a not equal to, there is no option for that right here. It's only less than or greater than. So if you ever have to do a not equal to where you want it to count both tails, you need to go down a little lower and select this two-sided button. When you select the two-sided button, it counts on both tails. But we don't need that this time. So I have it selected as less than. It highlights the dots, the sample statistics that are like mine and lower. There's two places where you will see the p-value given. Right up here above the vertical line, it says p-value is 0.15. Notice at the bottom of the vertical line, it actually says your observed statistic was 15 out of 50. Another place you'll see the p-value is right here. It tells you there were 15 samples out of 100 that were like yours or more extreme, which is a p-value of 0.15. I was actually pretty lucky. I got exactly the same p-value that we got when we were discussing the problem earlier with my other simulation. Again, though, if you do this simulation and you got something slightly different, that's okay. You might have 0.16 or 0.14. In fact, let me just real quickly reset this and let's try a new simulation. All right, I redid it. I did a new simulation and notice this time my p-value is 0.12, 12 samples out of the total 100. So my p-value is 0.12, which is very close to 0.15. Again, if I reset it one more time, let's just look at one more. Okay, I redid it again, and I see that I got this time a p-value of 0.12 with my new simulated distribution. Basically, if you do this simulation, you're going to get a p-value very similar to the 0.15 that I had. 0.15, 0.14, maybe 0.17, something like that. And so your overall conclusion about the null and alternative hypotheses should be the same. All right, back to the actual lecture guide. It asks us then to describe how we do it. All right, so I said that we put the sample statistic value in the count box. We selected the less than or equal to symbol to match the alternative hypothesis, and then we hit count. In general, though, what I would like you guys to always do is you're going to fill in these top three boxes and create your distribution. You're going to fill in the count box area and select the correct option here or the two-sided option here. And only when it looks like this, where you have your p-value displayed, you have all these red dots displayed and the p-value given, that's when you should do your screenshot and paste that into the actual answer to the problem. So instead of having to describe it in your homework solutions, you could just show me this, and it shows me what you entered in and the p-value you got, and then I'll be able to understand that you put it in there correctly, or if you had an error, I'd be able to help you with that.